Hello everybody, today we are going to talk about AirShiny and more precisely about inputs and outputs. Input and outputs in AirShiny can be complex, but they are really important. This is why I dedicate an entire video just for them. You remember in the first video, we have learned that when you look at a web page, like for instance this web page, it's called in computing science as a user interface. User interface. Sometimes you can also hear the word front end. This user interface is everything you see, from the pictures to the buttons. And here, of course, there is a user who can see things and who can interact. This is a hand on this user interface. But the whole web page is not what you see here. There is a second component that you cannot see and is ordinarily ignored. It's called the server or back end. In AirShiny, we are going to use the words user interface server. This is what you see, this is what you cannot see. This is why you can also find in some computing science lectures the words front end, back end. Why they are important is that when you click, for instance, on the user interface, for instance, I choose to change a color. I want to have a blue color. You can see that the web page changes. So I do something here. What happens is that this information, depending on the architecture, but this is how it's going to happen in AirShiny, this information is sent as an input to the server. From this input, a different cascade, a different chain of event logic can be deployed. For instance, if you click there, then what? Then give the color blue. So for this reason, there must be an output. And the consequence of this output here is that I see a blue dot and it comes back to me. So you can see that in AirShiny, we expect a server with all the, let's say, intelligence and actions, or logic at least, and a user interface in the front end. For this example, we are going to use the standard example provided by RStudio. This is RStudio. You go to File, then New File. There are different possibilities here that we may see later, but not today. And you can see here the Shiny Web App. Click on that. Then give a name. Today we're going to go to call that, for instance, test. You have the possibility to have the application either as a single file or as multiple files. It does not change anything for today. Just remember that if your web app should be quite complex and big, it's ordinarily better to have multiple files. Here we are going to use just one file for the sake of simplicity. And I see that it's something that I have already done, so I will take, so I'm going to go that test2. And immediately you can see that a R file with code is created as an example. Just to give you an idea of what it does, you can see here that there is Run App. If you click on Run App, several things happen. First, you can see that we run this code and then you can see that there is a web address. So this is 127.0.0.1. This is an IP address. An IP address is like a post address with streets, names, doors, etc. but for computers. Then you have 2 dots, and this number 5507 is called the port. What is important is that it means that the information created by this app is going to this address. So in practice, if we open a web page, we are going to see what is created by the app. This is only local. Local means that you can only watch that on your computer. On the computer of your friends, of your parents, of your teacher, it will not work. For it to work, we will see that in another lecture. But you can already see that we have created, within a minute, quite a nice web page. And you can see that this web page is interactive. We have on the right an histogram, and on the left, we have a widget. Here we have some data. This data is the time you need to wait before 2 geysers occurs. This is a geyser. It's a natural phenomena that occurs when boiling water from underground just blasts and produces this really impressive event. Then it stops, you wait, and it comes again. What you see here is the distribution, so the histograms of measurement of the waiting times. And here we have the number of bins. If we have only 1, then we have only 1 bin. If we have 50, then we have 50 bins. So you can see that there is an interaction. How does the code look like? First, you can see here that we need to install and load the library Shiny. Nothing will work if we don't do that. Then, as I presented in the previous video, there is the user interface here, and there is the server part here, and then the app that combines both. And this strictly corresponds to what I have drawn here. So now let's focus on this input and output. You can see that if we look at the user interface, there is almost nothing like input and output. Only here, plot output. While in server, we can see input and output. The input here, you can see, is only given here as input and then a $. The $, says that it's a variable that belongs to this other input variable, like a data frame colon. Where does this bins come from? Where is bins defined? If you look here, there is a slider input. The slider input is what you have here, and is one of the many available widgets that RShiny propose. These are widgets, and you can see the slider here. If you click on C code, you have the definition of this slider, and you should see somewhere here, okay, how to use it. So as first you have the name. So this is strictly inside. It's how to recognize the input from here. And then you have what you should see, like the title. And then you have information about the scale. So it should start, for instance, at 0. It should end at 100. And you have starting values. You have the possibility to have one-sided or two-sided sliders. In our case, we define a slider called bins with the title number of bins that should go from 1 to 50 and start with 30. And this is what we see, number of bins, 1 to 50. So when we click on this slider here, what happens is that we modify the input and we change the value of input bins. So this is directly related to this widget here. And this information is then taken in order to modify the histogram. Let's imagine another widget. We are going to change the colors by using, for instance, radio buttons. So radio buttons are buttons that you can only choose once, compared to checkbox where you can check several of them. If you want to use this kind of widgets, it's always the same. We see first in the code, so you have always server and user interface, and you can just copy and paste. Of course, you have here to take care about the structure of the page. I have not talked about that, but just to make it short, you have two parts, something called sidebar and main panel, which are sidebar on the left and main panel on the right. So here we are going to add the radio button. It needs a comma because these are input to this function. And let's just reload it like that. You can see that now, of course, it automatically opens this, but if we reload this web page, we see it as well. You can see that we have created another widget with the title. Where is that? Here, okay. With the title radio buttons and three choices, choice 1, choice 2, choice 3. And we select the one. Of course, here, if we choose, it doesn't do anything. So now we are going to imagine that we pick three colors. Yellow is going to be 1. Pink is going to be 2. And green is going to be 3. Okay, but what next? Then we need to use input. And here we are going to change, so the color is dark gray. We want the color to be different. Then we will need to have a condition on this. Condition, you remember, is described by if. So if input $, $, what? Well, we care about radio now. So we have if input $, equal equal 1, then we are going to define a color. My color is yellow. Similarly, if it's 2, if it's 3, this is pink, this is green. So you can see that we need to rewrite this information because this here, yellow, pink, and green, is just here as a display information. It does not communicate its further information to the server. The only thing that the server is going to receive are whether you picked 1, 2, or 3. And it's going to start with dark gray. And this color, of course, if we don't do anything, it's going to stay dark gray. So we need to add it here. So what it means is that when we change this radio button, it's going to change this value. It's going to change the color, and this color is going to be inserted as an argument in the histogram. Let's look at that. So you can see that by default, the first value is 1. This is it, selected equal 1. If we choose pink, it changes the color, and green. And of course, the other widget remains active. This is, of course, is just for one widget. You could imagine having several of them. For instance, an action button. Always the same. There is no shame in copy and paste. The action button. Save, reload, and you can see that we have an action button. Here, of course, it does nothing. If we wanted to do something, for instance, we are going to say if input what is the name action, equal, I think it's if you don't know what it does, so for instance, I don't remember what it does, you can just do print. You save and you reload. And then you look here in RShiny what it does. And you see here it's 0. If you click, it's 1. You see? I click 1, 1, 2, 3, 4, 5. Okay, so we are going to say that if it is if this is different than 0, my border color equal black. We change that here. And we are going to change as white. Let's try it. So basically what it says is that when I click on this button, this variable here that is white, basically it's not 3, it should be 0. It should turn black. So here, nothing. If I click, it turns black. So now you have understood input. So what about the output? You can see here that the only place where we have output is here. So there is a big function that is called render plot. And what render plot does is create an histogram. This histogram is sent back, you remember this is equal, to the output. And it's like for inputs, there is a $ to mention this belongs to output, and the name is this plot. Where do we see it? Here. And this means, okay, you are going to plot this graph here. Render plot and plot output are two standard functions to render a graph. So if I wanted two of them, and it doesn't work. Okay. So you can see that there is the possibility to have information going through inputs, that you get these different information through the input dollar, the name or the tag that you have chosen. There can then be the logic. The logic can be really complex. You can have functions, whatever statistics behind. For instance, the action button can read a file. And then to give it back, then you have different functions like render plot. Remember that RStudio has the whole library of as documentation, so you can see in RShiny how it works. You can render, so here it's just a plot, but you can also render a table, you can render a map. Basically anything that can be created, you can render a text. If you look, you see render print. Depending on what you want to display, there is a function on that. So that's all for today. Thank you very much.